In this video, I'm going to teach you about angles in a triangle, angles on a straight line, and angles around a point. Here, in this one, we got angles in a triangle. Angles in a triangle add up to 180. So 40 plus 30 plus something to give you 180, plus something to give you 180. Well, that's 40 plus 30 is 70. So you have 70 plus something to give you 180. Do inverse operation, 180 take away 70, 110. So the missing answer here is 110. You can always check that they add up to 180. Right. This is a special type of triangle. It's an isosceles triangle. What is an isosceles triangle? In an isosceles triangle, you'll know it's an isosceles triangle because of the two marks there. That is suggesting that this side is the same as this side, same size. So therefore, the two angles at the bottom are going to be exactly the same. Exactly the same. So we know angles in a triangle add to 180. We just saw that. So what we do is, just like here, we did 180 take away 70 to find the missing angle. Here, we need to do 180, yes, 180, take away the 40, 180, take away the 40, that leaves you with 140. So those two angles together are 140 degrees. But they're going to be the same, they are exactly the same. That's what an isosceles triangle is. The angles are exactly the same. So what you do is take the 140 and then divide by 2. Half of 140 is 70. So each one is now 70. Each one is 70. And you can check that they do add up to 180. 70 and 70 is 140. 140 plus 40 is equal to 180. This question is also an isosceles triangle. You got the two lines that are exactly the same, the two angles that are identical. It's just an isosceles triangle turned on its side, like so, like that. So therefore, it's these two angles that are the same. Here, these two angles are the same, but because it's been tilted to its side, these two angles are exactly the same. So it's the same question, really. It's exactly the same question. There you go. Angles on a straight line add up to 180. Now you've got to be careful now. I've seen people do this. This is a mistake. Let's suppose you got 40 here and this one 30. And I ask you to find this one. Well, for some reason people do 40 at 30 and then take it from 180. Now I'm telling you this. This has got nothing to do with this side. They're two separate questions. If I just move that away, look, if I just get rid of that, now you've got two separate questions. So this is angles on a straight line, add up to 180. 40 has something to give me 180, that would be 140. 30 has something to give me 180, 150. This is slightly complex angles on a straight line. You have got three angles sitting together. Remember, all three angles, that one, and that one, all three of them are surrounding that point and they're all sitting on a straight line. This is a 90 degree. So 40 plus 90 plus something to give me 180. Similar to this one. 40 plus 90 plus something to give me 180. Well, 40 and 90, 90 and 40 makes 130. Add something to give me 180. Do inverse operation, 130, 180, take away 130. That leaves you with 50. And you can check that all three angles around this point on a straight line do add up to 180. This one is angles around a point, full circle. Add up to 360 this time. This one was 180 degrees. This is 360 degrees. So here we have the 90 degrees. So we have 150 plus the 90 plus something to give me 360. Add them up. 240, add something to give me 360. do your inverse operation. 360 take away 240, that'll be 120. So the missing angle here is 120 degrees. I've got a question here, but I'm going to slowly develop this question, starting off with something very similar to this. I mean, here, angles around a point out to 360. So you do 160 plus the 90, add something to give you 360. That's 250. 360 take away 250 lands you with 110. This is 110. Now we'll develop this question slightly. I've turned that into an isosceles triangle now. The two sides are the same, so the two angles at the bottom of this triangle are going to be identical. This one and this one are identical. Just like we've done over here with this question, we're going to do the same thing here. So to find those two angles, you do, remember, angles in a triangle add up to 180, so you do 180, take away the 110, that lands you with 70, and then these, remember, these two angles together are 70, so you're going to do 720, split it up, divide by 2, 35. So these two angles are 35. Right, I would like to take this a little bit further. Let's say extend this line, make a straight line. I want to know what this is. Now we know these two angles, this one and this one, are sitting on a straight line. There, straight line. Angles on a straight line out to 180. So 35, add something, that's something there, is equal to 180. 180 take away 35, inverse operation gives you 145. You can check 145 plus 35 should make 180. Right, let's take that a bit further now. I'm going to extend this line, make a cross. So you've got a straight line here, a straight line there. I could ask you what this one is. Now in a previous video I said to you, when you've got a cross like so, two straight lines, the opposite ends of that cross are the same. They're exactly the same. So if that was 35, that would be 35. You can put 35 there. Or you could have said, you could have easily said, angles in a straight line, if you see that, angles in a straight line add up to 180. So 145 plus 35 does make 180. So you could have done it that way as well. Right, take this diagram a little bit further. Alright, what I will do, I'll make a straight line going that way, but I'll identify that with this line to say they are parallel. In a previous video, we looked at angles in parallel lines. We talked about corresponding angles, alternate angles, co-interior angles, vertically opposite, we just looked at. So these are parallel, so you can start thinking about those type of angles, the F's, the Z's, the C's, etc. I could ask you now, like, what this angle is here. Well, don't start guessing numbers. You need to have a reason for it. Well, I found a reason. I would say to you, find a pen. Right, I have identified an F right there. It's an F like this. And remember, this angle, the two angles facing down, are the same. So if this is 35, obviously this is going to be 35 as well. Now, what else can I do with this? I could take this a little bit further and say, well, That's a right angle triangle. So now I want to identify this angle here. Then you can easily say, well, angles in a triangle add to 180. So you make that a 90 because that's a right angle. Then you do 90 plus 35, add something to give me 180. Now I can do that quickly on the calculator this time, save your time. 90 plus the 35, 125. 180 take away 125, that gives me 55. Right, just let's be clear about this, that's 145. Right, what else can we do with this? Well, let's take this a little bit further, taking a bit of a risk here. Let's suppose, alright, make this line go a little bit down, like this, from this point here. Now, I will say to you, this is my right angle. So what is this angle over here? Well, you can see it's 180 degrees, angles on a straight line. You've got this one, plus the 35, they do add up to 108, should add up to 180, so that's 90. So I'm going to add these two up and take it from 180, 35, 90 plus the 35 gives me 125, 180 take away 125, that gives me 55. Well, not surprisingly, here I've got a cross, just made a cross here. Can you see the cross over here? I'm trying to highlight that. See if I can highlight that. Here I've got a cross. Not surprisingly, this is 55. This is also going to be 55 because that's a cross angle, vertically opposite angle. Maybe I can take this a little bit further. Let's say, right, there you go. And I'm going to identify this one as 70 degrees, and I want to know what this one is. Well, I have a four-sided shape here, and we know in any four-sided shape adds up to 360. So you add these three angles and take it from 360. So 70 plus the 160 plus the 90, 70 plus 160 plus 90 gives you 320, and then 360 take away 320 because angles around in a four-sided shape add up to 360 is equal to 40. This one here is 40. Okay, I think I'll stop now.